right, sir. Good morning, everyone. And a couple of new joiners today. May I know who are they? I think Varun, Virana, Ajay. I think you guys joined today, I guess.
Hi Sandeep.
Yeah, hi, Virana.
Actually,
You
yesterday I
joined today?
joined little late actually.
Okay.
So after that I listened the recording session also.
Okay, good. Yeah, okay. You can mute.
Thank you.
Yeah. So, right, sir. So, you came today? Right. So, I'll talk to you later after the class, okay? Just 8:40. Just start the recording. Yes. Right, sir. So, what we have discussed yesterday, people who have joined today, no need to worry, you'll get recorded session, and we didn't discuss that much in depth. Right? So, any key points from yesterday's class? Sir, any points from
Yeah,
yesterday's class?
yesterday we have discussed about 3 points: ICM and infrastructure as a platform, and configuration management,
Very good.
and CI/CD, continuous integration and continuous deployment.
Yes, very good. And apart from that, we have discussed so many other points as well.
Yeah,
Right?
we
Yeah,
have
how that
discussed.
life cycle will be there.
Yes,
Yes, yeah,
tools
Lokesh, go
of
ahead.
Yeah,
Yeah.
yeah. How
Right.
that life cycle will be there from the developer to the end user, and also we have discussed about the types of servers at each point, and
Mhm.
also the testing
Yes,
phases. We have just given
yes,
a
yes, yes.
quick.
Right. Very good. Yeah. Right, sir. So, yeah. So, coming to the software development life cycle that we discussed yesterday, right? Okay. So, what is the first phase? Developers will be writing the code for the application. Okay. So, the first phase would be development, and the second phase, once the developers develop the code, then what is the second stage, sir?
build the code.
Yes, they'll be sending the code to the build environment. So that I'll make it down as building is the next phase. So once the product has been built, okay, the next phase would be, sir, please go everyone on
Test,
mute. Yeah,
testing,
testing, very good. So once the application has been thoroughly tested, then
deployment.
we'll be deploying this application into production servers, right? So that end users can access the application, right? So now today we'll understand, okay, now who is responsible for developing the application? Developers. Who is responsible to build the application? Build and release engineers, okay. And who will be testing the application? Test engineers. And who will be deploying the application? The deployment team. You can call them as deployment engineers, okay. Now let's try to understand who will be there in the dev team and who will be there in the ops team. Okay, did you remember my yesterday's uh, theoretical definition about DevOps, right? It builds, DevOps is a culture which emphasizes and establish the effective communication and collaboration between the dev team and ops team. Okay, that is a big statement. Okay, we'll break it. Don't worry. So, yeah, suppose now the first team would be developers, right? I can write them as developers. Okay, let me write this as coding. Okay, once the coding is done, the next phase would be building. Okay, I'll this one is let me fix this. Once the code has been successfully built, it will be sending to the test environment. Right? Let me change the color as well. Let me put red. Once it is done, then we can go ahead and deploy it to the production environment. So we can mark it as deployment. I'll put deployment. Now, out of these four disciplines, who will be considered as dev and who will be considered as ops team member? Okay. The first thing is the person who is responsible to write the code is called developer. So, obviously, dev team member. So, I'll write the dev team members over here. The dev team first contains developers, right? And it contains, look at the diagram. The next page is building. It also comes under development only. We call it as build engineers. Okay. Next, testing. Testing also comes under dev phase in DevOps. Okay. Those test engineers. Okay. On ops side, by looking at the picture, now what we can say who will be there in the ops team? The deployment team, right? So I'll name them as deployment engineers. Okay. Only these members will be in ops. Are we missing any other team members? Let's try to understand. Okay. So the person who is building, right? So he's building the product. He's building the application, right? He'll be taking the source code. He will be building the application out of the source code. So it is a combination of two things: build and release engineers. So one person will be building, second person will be releasing the application into some other place or to some server environment. Okay, so we call them as release engineers. I'll put the release engineers in the ops team. Okay, build engineer will be building the application. Release engineer will be releasing the application and he'll be putting that application into some place. That is his responsibility. Okay, now look at the picture. If you can think, right, entire life cycle is done over here. But if any developer wants to write a code, he need a laptop. Yes or no? Laptop required an operating system. It required the user account. It required some softwares, right? So somebody would be doing the task in the back end for him, right? Whom we call it as system admin. So who will be there in the back end? System admin. So we are having servers also. In servers also there will be installing some packages. They'll be configuring the same thing. So I'll call it as server admin. I'll just put it as okay. Now, if my application wants to write some application oriented data, it wants to store the application oriented data. Let's say if there is an e-commerce application, it needs to store how many users are there, what are the items that they have ordered, what is the order amount, all these things in general, these are called as application oriented data. This data will be stored in a database, right? Each application will be attached with the database, right? So who will be administrating that one? A DBA person would be there in the backend, database administrator. I named it as DBA. Okay. Suppose your application contains some video files or audio files or some images. In general, we are not or we will not store them into a database. We will be storing into a separate storage space. Okay. Now, in order to administrate that, we require a storage admin. Yes or no? Now, all these are part of as a project, right? Okay. So they need a communication between each and every team, right? So there should be a network through which they can communicate. So all these people will be associated, communicated with the network. Then who will be administrating that network? Network admin also would be there in the backend. Right? So all these guys will be a part of the ops team. I'll name it as network admin. Right? So let's try to write them on the screen here. Okay. First we'll call it as system admin or server admin. Look at the picture and tell me. Next, DBA, database admin. Next, storage admin. Next, network admin. Right? So all these persons or all these team members, all these teams are responsible or will falls under the operational team. Dev plus ops is called DevOps, right? So as I said previously, if all these people will work in silos or individuals, then there is a communication gap between everyone. So with DevOps, what is the culture? I call it as culture, right? So what is the cultural difference that it made? Okay, before DevOps, each and every person will be sitting individually, no communication between each and every team. But with DevOps, what they said is, okay, guys, Dev and Ops, all members, okay, you form as a team and then start doing work so that they imagine that, okay, if we people sat together and work, we can have the effective communication between each and every person. Okay, suppose some person installed Java 1.8 and Dev, the same thing will be available for the same information will be available for all the team members. So that's in QA, if they want to deploy the application, if they want to test, send the application to testing environment, okay, definitely they will be putting the same Java version over there because they are having that information. Okay, something goes wrong in the dev server, somebody will fix it. Okay, how we fix it, what is the error exactly? Then the thing will be discussed among the team so that everybody is having a glimpse of that. Okay, so this is what the basic idea. So what they said immediately, they put the cultural change, simply saying that okay, dev team and ops team, everybody just form as a team and start doing work. Okay, to eradicate the differences between the communication gaps between each team. Okay, so before the DevOps, imagine that the application deployment to the production environment. That means right from the development to the deployment. We have various phases, right? Suppose if it is having 6 months of time, but after introducing this culture, they said everybody, okay, dev team and ops team sit together and work. They said, right? So all people started together and started working. Okay, even after 1 year also, the product is not getting released. Why? Because their mindsets are different. If I put a Russian boy and a Chinese guy together, they'll be having a communication gap, right? So here also, these developers mindset is different from this operational guy's mindset. Okay, suppose if any developer wants to communicate, suppose this operational guy contacting any developer, hey developer, what are you doing? He might be saying that I am writing code for some part of the application. Okay, for this feature I am just writing the code, right? Or else he might be saying that my code is ready, I am uploading the code to source code repository, which we have discussed yesterday, right? So multiple developers will be working on the same project. They will be storing individual code. They'll be combining entire code and they'll be uploading the code into a server, which we call it as source code repository. Okay. They'll be saying that uploading the code, or I'll admit that it's technically called as version control system. Okay. Why it is called as version control system, we'll see when we go to the concepts of the version control system. As of now, just for your confirm information, just I'll say uploading the code to source code repository. Okay, or else he'll be saying that my part is done, the code is in testing phase, right? I have sent the code to testing. This is what the mindset of a developer, right? But on the other hand, operational guys, what is their mindset? Suppose if you ask a server admin, he'll be saying that I am installing an operating system. Okay, or else I'm creating a user account. I'm doing some configuration changes of the service. I'm starting a service. Yes or no? This is a different mindset. Okay, so if these guys wants to establish the communication, it's actually not happening. So with that putting in their mind, they said that simply if you combine both dev and ops as a team, which actually will not help. Okay, either dev team has to be think like operational guys, or else operational guys has to think developers, like developers. This is what the basic idea. Okay, so what they have decided is developers till now whatever the work that you are doing, right? You just follow your working style. Okay. Now operational guys. Now what you need to adopt? You need to adopt the same technique, like how this dev team is doing. Okay. Say they are writing code, right? You also start writing code. Okay. Immediately operational guys got heart attack because they don't know how to write code, right? Developers will be knowing Java, they'll be developing code in .NET or Python, C Sharp or something. But operational guys, they don't know how to write the code. Okay, they said that you don't need to write the code like how these developers are writing. Okay, you don't need to use the same languages. We are having some kind of small scripts. We'll use some kind of tools. By using the tools, you can also start writing some code. Okay, like how developers are working. Now, suppose as we discussed in the previous class, suppose a group of servers. I want to install a package. Then with the before to DevOps, the approach is manual. People will be going in, logging in, and then they'll be executing the task. But with DevOps, what we have discussed, we will be writing a script file for that. Okay, I want Java JDK 1.7. I want Tomcat this version. I want this service. So all the requirements they will be writing a script. Okay, they'll also write some code. This code they'll be executing in this all group of servers, right? So how developers are thinking likewise, even operational guys also started writing code. Even they have adopted the technique of writing code like developers. Okay, but not the using the same language, some easy languages. Okay, which we'll be doing in our future classes. Okay, so operational guys also started writing code for the for their infrastructure as well as for CI/CD. Yesterday we have discussed, right, for their configuration managements. So for whatever the discipline that they work, they also started writing coding. Okay, even not a single guy, a single operational guy will be there, right? Here, there also a group of operational guys will be there. They will also write some part of pieces of the code. Even they need to have the entire code in a source code repository or some repository. Okay, which means they need to also upload the code to the server. And say source code repository. Here also there is a code. Okay, so they are also writing the code and they'll upload the code to the source code repository. Okay, it's not that simply I just write the code and I'll just execute on all the group of servers. Not like that. Even that code also needs to be tested. Okay, if I'm installing Java some version, I need to verify, right, before installing on 100 machines. I need to verify on a single machine whether the same Java version I have written the code, it is getting installed or not. Even it needs to be thoroughly tested before deploying it to a group of servers. So now you can compare the mindset of both dev team and ops team, right? Now if they want to communicate with each other, okay, so developer is asking operational guy, he might be saying that, okay, I am writing some code to install some databases. Okay, operational guy asks the developer, developer will be writing, saying that I'm writing code for some functionality. Hey, ops guy, what are you doing? I'm uploading code to source code repository. See the mindset. Both the mindsets became similar, right? Yes or no? And what is the phase? Like, what are you doing? So my code went to testing. So I just wanted to have a cup of tea outside, so I just came out. This is what this is how they brought both dev team and ops team minds together in order to achieve better results. Why we need to do all these things? The main goal is the application reaching time from the development to the deployment should be very less, so that customer can get some revenue out of it. It's not that simply, okay, today I'll write some application or some I'll develop some feature, I'll simply throwing that application to deployment for client purpose. But what about the quality? We should not get compromised on the quality as well, right? So application should be delivered faster as well as quality should not be compromised, right? These are the main goals. If you look at any product, these are the main two goals. Okay. Now, for this to happen, we'll be using some kind of tools. Okay. Let's try to fit the tools over here. Okay. Now, for coding, I'm not comfortable with this. Just let me go with this because in Linux I used to use this. Okay. Somewhere. If I fix this, the fonts will be fixed. Okay. The first part is coding. Okay. In order to write the code, people might use what are the programming languages that you know, sir? Any programming languages that you know? Java, .NET,
Java, C++,
Python, PHP,
Python.
C++, right?
Yeah.
Java, Python. Uh, so any development language they can use. Okay, PHP or Ruby, okay, .NET or something. Okay, etc. Right? Now once they write the code, they'll be uploading the code to some. They'll be storing the code at some repository, right? Source code repository. They'll store the code in some server environment. Okay. Now, in order to maintain the source code repository, here we will be using a tool called Git. Okay. As a DevOps engineer, you need to write the source code. This is the part of few developers. Okay. So they in general they will be pushing their code to source code repository. Just you need to have an idea in order to clear the interviews. That's it. Okay. Then again, that's a different topic. Let's go with the flow. Okay. So once development is done, they'll be uploading the code to source code repository. For this source code repository, which tool that we are using? Git as Git is our tool. Okay. Next, from here, what is the next phase? చెప్పండి సార్
Build, build, build,
డెవలప్ కోడ్ రాసిన తర్వాత
build the code.
building. Yes,
Yes.
they need to build the code, right? For building,
Yep.
what is the tool that we'll be using? Okay, each development tool has some build tool. Okay, suppose you are developing Java. Okay, the developers used Java. You can use either Ant or Maven, out of which Maven is the better one. Okay, if you have .NET, the build tool would be MS Build. If you are using Node.js, you might be having npm. Okay, and you have gulp, grunt like this. Okay, gradle like this. So many build tools are there. So all these build tools are depend on the development language which was used by the developers. Okay, now out of which we will be learning Maven and npm, and I'll show you how to work with Python code as well. Okay, there is a difference between interpreted languages as well as compiled languages. We'll see that in the coming days. Okay, I'm not going that much in depth, but so these are the tools that we will be learning as part of building. Once the build is done, next testing phase.
Release.
Now you might ask this question, sir, are we responsible to build or to test the application? No. Okay. Testing, how developers are developing the code, right? For testing, there is a separate team called test engineers, right? They are responsible to write the test cases. Okay. So for this testing, so yesterday girl came, right? She is Shruti or something. Shruti. Okay, she invited the call today. Okay, if you are a test engineer, you might understand this, but on testing side, for the automation, they'll be using Selenium as a tool. Okay. Now after testing, we need to, what is the next phase?
Release.
Deployment, right?
Deployment.
Okay.
Deployment, you can say first release and then deployment. So I'm not including the release part over here. Once we go into the build and release part, we'll see that. Okay. Now directly I'll read the deployment. Uh, Now deployment to the servers. Okay. Each application has different servers. Application servers. Okay. Web servers. Okay. Email servers. Like this. So there are so many servers, and we need to learn how to do that. Okay. Now for the deployment, we'll see Tomcat, and we'll see Express.js, which is a part of Node.js. Okay. I'll just write it over here. If it is Python, okay, so whatever the framework that it is using, either Flask or Django or is a fast API, REST API, something, so many things are there. We'll see once we enter to the Python thing. Okay, how to build or how to deploy the code. We'll see that. Okay, as of now, just a Tomcat. Now, what is our major responsibility, sir? As a DevOps engineer, you need to perform CI/CD, right? CI/CD means
Yes.
if any developer
Continue. Continue.
commits any new code, we need to automate the entire process, right? So immediately the code needs to send to the building environment. The code has to get built and released, and then it has to send that to the testing team. Okay, so that all the test cases needs to get executed automatically. Okay, no manual interruption should be there. They'll be writing the test cases. We need to integrate their test cases. Okay, somebody will be giving the test cases to you. You need to know how to integrate the test cases. Okay, and then once all the test cases are passed, then we need to deploy it to the servers. So developer changes anything, just modified some code, automatically the entire process, taking code, building, training, testing, and then deployment, all these things should be automatically happen. In order to make this automatically happen, we will be using a tool called Jenkins. Jenkins is responsible for CI/CD. There are some other tools as well for CI/CD, but Jenkins is most popular and widely used. Okay, almost I am using it from the past 8 or 9 years. It is that much popular. Okay, so within Jenkins, so this is the tool that we will be learning. So within Jenkins, we will make CI/CD. Okay, now what are the other tools that are included here? And the first thing is the first step. I'll mark this one as some color. I'll make this one as the first tool we'll be learning Git. Okay, it's not serial wise. Just I'm just writing. Okay, the second thing is build. Just I'm counting it. Okay, and the third thing, we don't touch Selenium because we are not here to become a test engineers. If your previous background is testing, then you can put that. Okay, and the third thing is deployment to Tomcat servers or some web servers. Okay, this is the third thing, and then this is the fourth tool or fourth thing which we will be learning. Okay, now in order to deploy, we need to create servers. We need to have servers, right? If you have server, then only on top of it we can go ahead and install Tomcat, JBoss, or anything. So if you want to create server, we need to know how to create servers. For that, yesterday we have decided right where we are going to create the servers. We'll be using, sir, where we are going to create the servers. Hmm? Cloud. That to which cloud? AWS cloud. Okay. On AWS cloud, we are going to create the servers. This is, I'll say 1, 2, 3, 4. I'll just name this one as 5. I'll just mark it as 5. And next, okay. Now the servers are created. Imagine I want to run some configuration management. Suppose I have created some 10 servers. Okay, on all the 10 servers, I want to make homogeneous servers, which means all the 10 servers should have the same configurations, same versions. Okay, how we are doing that? We are doing with the configuration management tool. That is what the second responsibility of a DevOps engineer, right? So first, let me write the three major responsibilities of a DevOps director. What are those? The first thing is infrastructure as a code, where we'll be writing a script and we'll be creating hundreds of a number of servers at a time. And then configuration management. Okay, so that will make all the servers homogeneous. Okay, suppose if it is as there are, if I request some 10 database servers, all the 10 database servers should have the same versions, same configurations. Okay, for that we'll be doing configuration management. What is the last thing? Continuous integration and
CI/CD,
continuous
continuous deployment.
deployment. Right? Coming to the infrastructure as code, we'll be doing it on AWS cloud, and then okay, we'll be learning Terraform, or even with not, I'll just put it here. Okay, even with Ansible also we can do this, but we'll be learning Terraform over here. Okay, coming to configuration management part. Suppose okay, before writing the script or before automating the task, suppose I want to install some package on group of servers. For that, I need to write a script. Okay, before that, just we need to know the manual process, right? At least you should know how to install a package. Then only we can write the code. Then only we can automate the process. Okay, if I want to create your user account on 100 servers, at least I should know the manual process, how to create user account. Okay, so manual process we should learn. For that manual process, what we are going to learn? We are going to learn Linux. Okay, and then we will be performing the automation tasks by using a configuration management tool called Ansible. Okay, along with Ansible, Chef, Puppet, some other tools also there. Don't waste your time. Okay, out of which Ansible is most popular and widely used nowadays. Okay, with Ansible, even you can create this infrastructure as code. You can write a script. Okay, uh, and next, for coming to CI/CD, this is the CI/CD process, right? Where is that? Now CI/CD, Git, Maven, or build tool, Tomcat, Jenkins. All this comes under CI/CD. So let me write this statement over here. Okay. All manual tasks. First we will see all the manual things. Git, Maven, and then I'll say Tomcat. Okay, Tomcat. So how to build manually, how to get the code from Git manually, and then how to deploy Tomcat manually. All the things manually we'll do. And then with the Jenkins, we will be automating the entire flow. This is the flow. Okay. For this, we'll be creating some kind of jobs. We'll see that. Okay. In future, we'll be writing some scripts over there, how to do the CI/CD pipeline scripts, everything. Right. Now, along with these tools, now you understood, right? Which tool falls under which category or in which area? Let me close this. Right. Coming to CI/CD, Git, a build tool, anything, any testing tool, or any application server or a web server. It might be Nginx, it might be HA proxy or something. Okay. Don't get worried about all those terminologies. For now, just treat everything as a server. Okay. Now coming to infrastructure as code, any cloud, and you need to know how to automatically create a number of servers, how to create the infrastructure, how to do the networking configurations. Everything will come together, coming under the infrastructure as code, as well as the configuration management part, Ansible. Okay, manual thing, Linux, automation, Ansible. Manual thing, Git, Maven, Tomcat, and automation, Jenkins. Okay, along with this, we'll be learning containerization technology. Okay, what is containerization technology? For now, you can't understand, but I'll just try to give a brief idea. Okay, yesterday we have discussed a point, right? Suppose if a server is able to process some 2000 requests per limit time for 5 minutes of time, what happens if 4,000 request comes? We will be scaling this application, yes sir, no, we'll be scaling the server, right? So we'll be adding one more server. Previously, one server is responsible to serve all your requests. Now, two servers will be responsible to serve your application. Like this, suppose all of a sudden they find a spike in the traffic, they might be adding few more servers, let's say some 3 or 4 servers at a time, right? But in order to add these servers, if you go for manually adding all the servers like physical infrastructure, it will take days of time or months of time. If you go for cloud, it will take 10 to 15 minutes of time. To add a new server, it will take 10 to 15 minutes of time, because the server needs to get created in the backend for you, and operating system needs to get installed, and then even the server has to get rebooted. Just it needs to get started, it needs to get booted. It will take 10 to 15 minutes of time, right? Now, as an example, I said Amazon or Flipkart is announcing some flash sale. Okay, now they want to add some 3 servers. Okay, in order to add a server, it is taking hardly, let's say, 10 to 15 minutes of time. For easy calculation, I'll say some 15 minutes of time. Okay, which means the flash sale itself will be like 10 minutes, it will be like half an hour or 1 hour, right? Suppose if it is an half an hour, in order to add a new server, it is taking 15 minutes. Then within the 15 minutes, all the existing servers will get crashed, right? So that obviously nobody can order. Even if they enter Amazon.com or Flipkart.com, the company website will not get loaded, because it is having too much burden on the existing servers, which are responsible to serve the application. Yes or no? So now in the real-time world, even I don't want this 15 minutes of time, within a second or within 2 or 3 seconds, I need to add a server. If I could add the server within 2 to 3 seconds or a fraction of seconds, then definitely it will add advantage to my product. Yes or no? Okay. That is what actually where containerization comes into the picture. In order to provision a VM or in order to create a server, okay, I will talk about VM till now, we'll talk about it tomorrow, but in order to create a server, it will take minimum 10 to 15 minutes of time, but in order to create a container, it will take most probably half a second or a second, or couple of seconds. Okay, so that is where technology is there. That is what the kind of technology which the real-time application requires in the current trend, current market, right? So by using a technology called containerization technology, we will be creating the servers within fraction of seconds. That is where we will be using Docker as a containerization technology. It also comes under infrastructure as code, right? How we are creating servers manually, here also we will be creating containers manually. If you want to automate this, as of now I'm giving the rough idea. Okay, it's not exact the term, but in order to put you in the flow. Okay, we'll be learning something called as Kubernetes. Okay, imagine Docker is a manual stuff and Kubernetes is an automated stuff, like all the other tools. Okay, nowadays everybody is asking Kubernetes, Docker and Kubernetes. So you should put it in your resume and all the applications in real time. Currently, all majority of the applications, 95% of the applications are Docker and Kubernetes, because of the power of containerization. Within a second they can create, within a second they can destroy, right? So our major focus would be on all these tools. Okay, now you may ask, do we really need to work on all these tools if you join as a DevOps engineer in the company in real time? That's not the biggest question, right? Because there are so many things to learn, but depends on the company which you got hired. Okay, suppose you got hired to a startup, then everything you need to do, right from creating the servers, configuring the servers, doing CI/CD. If it is containerized based servers, you need to create containers, you need to do the automation, and everything you need to do. Okay, if you joined a medium scale company, you might be doing any two of the tasks. Okay, either CI/CD configuration management or infrastructure as code, or CI/CD, okay, or containerization technology and CI/CD. Any two of them you'd be working. But if you join in MNCs, you might be working on any one of these disciplines. Okay, right? So currently, I am working in a product-based company, which is almost having a 2000 plus employees, and our team is having 16, and I am leading the team. So currently, my main focus is Docker and Kubernetes. I am working on this, and other people are working on CI/CD and all these things. If they get stuck, I need to help. So I need to look up on all the things. It all depends on the place, the position which you got hired. Okay, right? Sir, any doubts still so far? Any doubts? Can I consider it as no? Right? So on outline, we'll be learning all these tools. Apart from this, okay. If time comes, right, so we'll be um, like a webinar kind of stuff. We'll connect one day, and we'll try to set up Prometheus, Grafana, okay, and Promptile for logs. We'll see this stack as well for monitoring purpose. I'll just do monitoring. Okay, like a workshop, you can say. Okay, it's not that for one day I will do Prometheus, another day we'll do Grafana, and another day we'll do Promptile. It's not like that. We need to sit together for 2 to 3 hours so that we can link with each other things, right? So we'll be taking a workshop. We'll call it as a workshop. Like 3 to 4 hours, we'll conduct the session, and we'll be concluding them in that day itself. Because the syllabus is very huge, we need to cover so many things, right? So in order to complete the syllabus, minimum I require 2 months. Minimum 2 months. 2 plus you can imagine. Okay, officially classes are from Monday to Friday. It's not that on regular Saturdays I'll take the class, but whenever I take the class on Saturday, I'll take minimum 3 to 6 hours, depends on the topic. Suppose suppose we need to do a CI/CD project. We cannot do that on a daily basis. If you do that daily basis, 1 week time will be gone. Okay, if you put that on Saturday, the entire integration part, we'll be learning each and individual pieces, right? The CI/CD part. So we'll be integrating everything on a single day. We'll see how CI/CD goes. Yes or no? Those things will be doing on Saturdays. Those kind of stuff, so that we can complete the syllabus within what 2 months. Otherwise, it will take minimum 6 months to complete the entire syllabus. Okay. Apart from that, what are the things that comes to my mind, or what are the things that we are facing in our real time? Okay, we'll be discussing the issues, and the journey will be keep on continuing, keep on going, right? So let me wind up with this today. If you guys have any doubts, you can ask me. And before coming to the next classes, I required everyone to open an account in where aws.amazon.com is the official website for AWS Cloud. Go ahead and create your account. It will ask your debit card details. They'll charge 2 rupees, and within 24 hours, your amount will be credited into your account automatically. Okay, you can use it for free. Majority of the services you can use it for free up to 1 year. This is the main thing, because we need to practice. Where we can practice, we'll be creating servers on cloud. Okay, right? Any doubts? Any doubts,
Uh,
guys?
Sandeep sir,
Yeah, yeah. Who is this? Yeah, Ravi.
uh, if
Right.
you if you don't mind, whenever you are scheduling a class on Saturday, can you please intimate priorly so that we will also prepare for that.
Definitely, definitely, definitely. When I
Yeah,
start on Monday, I'll be definitely having an idea whether to conduct class on Saturday or not because of the topic.
yeah,
Okay, definitely I'll inform you. Okay,
yeah. Thank you
prior to
so
that,
much.
3 to 3
Yeah,
4 days
thank
I'll
you.
inform you. Everyone.
Yeah,
Right.
thank you so much.